Hello, this lecture is going to be on the pre-lab for lab number 3, designing with the potentiometer. So what I'd like you to do is I'd like you to get into Canvas and print out the pre-lab for lab number 3 along with a supplemental sheet that comes with the potentiometer. We're going to start out by just discussing here the potentiometer real quick. If you take a look at a potentiometer here, it's a 3-terminal resistor. It's nothing more than a 3-terminal resistor. Matter of fact, if you take a look at all these knobs up here at the top of your trainer, they're all potentiometers, as well as these two right here for the power supply. They're nothing more than the potentiometer we're talking about now. We're going to use the 50k ohm potentiometer or 50k ohm pot in the lab, but they come 100k, 200k, and what they're representing is the total resistance from one end to the other. If it's a 50k potentiometer, the total resistance from this point A to this point C, if you measure that, it's a constant 50k ohms. What makes it a 3-terminal device is you have a pickoff point or a wiper that when you vary the resistance, and I'll show you how to do that in a minute, this point slides up and down here. So if this is a 50k ohm pot, which is the one we're going to use in the lab, and we vary this resistance down to this point where this arrow here, or this third terminal is down here at the bottom, I want you to notice that the resistance between point C and point B will be 0 ohms. And if you move this point here and you vary the resistance so point B is up to point A, and then you measure the resistance between point B and point C, C being the reference, you'd get a full 50k ohms of resistance from that point to down here to C. So the advantage of using the potentiometer is really in the voltage divider characteristics that it will exhibit. In this case right here, we have an E, source of EMF E out here, and we'll give you an example down here in a minute, but here's our source of EMF, and I want you to notice that whenever this wiper, this resistance is varied, this is your output here. This is going to go to another circuit here in future labs. This is going to be your output voltage from the potentiometer, but it's going to be our source voltage. This is going to be the source voltage that's going to feed other circuits. So even though I'm labeling this as V out, it's what the potentiometer is producing in terms of voltage out. But if we have this pot, if we change this pot, vary it until this wiper's at the top, you're going to get a full E out. Whatever E is, that's what you're going to get out. And if you vary the resistance so that this terminal B is down at C, you're going to get 0 volts out. So this potentiometer is going to vary between 0 volts and the full voltage of E out here. So why would you use something like that? We're going to use the potentiometer in a lot of labs, and the reason we're going to use is because we're going to need very, very small voltages. Let's say we need 50 millivolts to go into a circuit, and we only have a 10-volt source out here. Do you know how difficult it's going to be to try to vary that power supply to get down to 50 millivolts? When you have 10 volts to work with, it's very, very difficult to get that. And with the noise that's generated on these lines, it's going to be almost impossible. So what we're going to do is we're going to run this 10 volts or this sinusoidal waveform, whatever. This could be DC or AC. It's going to be DC and AC in different labs coming up this semester. What we're going to do is we're going to run this across the 50k pot, and then we're going to vary that resistance so that we can pull off the 50 millivolts. So notice, to get the 50 millivolts, that wiper is going to be way down in here somewhere. It's not going to be close to the top. That's going to give you the 10 volts. But these potentiometers give you a very, very high resolution in trying to pick off the voltage. It gives you a lot of linearity to slide between this point and this point. So let's take a look at a potentiometer here. This is what it looks like. It's going to be difficult to see, but you're going to see it in the lab. This is a potentiometer here. And notice it's a 3-terminal device, and if I turn it upside down, if you take a look, difficult to see, I know, but there's your 3 terminals. This will be A, this will be B, in the center, that's the wiper. This is C. No, they're unilateral devices, bilateral, and there's no, they can go in a circuit either way. It's just a resistor. It's just a 50k ohm resistor between this point right here and that point down here. A lot of times they'll have the resistor even drawn on the side of these things so you can see it. And then how do you vary the resistance? So if you take a look at the very end, now on here you vary the resistance by these big knobs, okay? But on these potentiometers, what you'll do is you're going to have a little screwdriver that I'll provide to you, and that little screwdriver will fit right here at the end. And you'll vary this. And it has, this possibly has 30 or 40 turns to it. When you turn this, what you're doing is you're sliding this wiper. You're sliding this what I referred to as terminal B. You're sliding it up and down that potentiometer. So I'm going to have you get familiar with the potentiometer by basically taking it and measuring from one point to the other. You're not going to measure from this point here to this point here and vary this, because that's always going to be 50k ohms. Think about that. It's always going to be 50k from A to C. What you want to do is you want to pick point C to point B. You want to take one of the ends of the potentiometer, in this case C. We'll use that as a reference. And then, so what we're going to do is you're going to end up getting a ohm meter, and we're going to put it, the black lead here, and the red lead here in the center. And then we're going to vary this, and I want you to see how you can change the resistance of this thing. Well, in our lab, I asked you to do a design. If you take a look at the pre-lab, what I'm going to have you do, and print this out. This is in Canvas. I already told you to get this printed out. This week's laboratory session serves as an introduction to understanding potentiometers. The techniques learned in this lab will be used in subsequent labs. Referring to the circuit below, and here we have the circuit, and I redrew it in a minute for you. Calculate the values of R1 and R2 so that the voltage at terminal B, or the wiper, I called it, of the 50k ohm potentiometer will range between, there's two designs here, 1 volt and 5 volt, and 3 volts and 7 volts. And it explains how to do that here. This is the pre-lab that has to be done. When you come to class, the first thing we're going to look at is we're going to look at your design. Design 1 and Design 2 on paper. To get credit for the pre-lab, you have to show the design complete with all the calculations. Let me give you an example. In this case right here, what I want you to do is I want you to design so that the voltage range from A to C is 4 volts is less than or equal to the output voltage, which is less than or equal to 6 volts. So notice what I did is I put a resistor up here. That's going to be a fixed resistance. I put a resistor down here. That's a fixed resistance. I got R1 and R2 that's on either side of the potentiometer, which is going to allow for a voltage divider set up here. You're going to see that in a minute. And in this design, in this example design, I want, when the wiper's at point A, I want 6 volts. And when the wiper's at point C, at the bottom of the potentiometer, I want 4 volts. And to get those limits, you have to put in fixed resistors, R1 and R2, to do that. If R1 and R2 isn't there, you're going to vary between 10 volts and ground every time. I just explained that. Look at the previous circuit. If you don't have R1 and R2 there, you're not going to get any limits other than 0 volts and 10 volts, or whatever this is out here. So how are you going to design this? You're going to put an R1 and an R2 in, and we're just going to use the voltage divider rule. At point A, by the voltage divider rule, VA has to be equal to 6 volts, which is equal to the total voltage in 10 volts times the sum of the resistances from that point to ground, which is 50k ohm, that's the potentiometer, plus R2, divided by the total resistance. You get a linear equation, and you get it in a standard form. The first equation is 6R1 minus 4R2 equals 200 times 10 to the third. Then you do another calculation. VC, the lower limit, is equal to 4 volts. That's down here. That's equal to another voltage divider. 10, total voltage into the circuit, times R2, look at the circuit, times R2, divided by the total resistance. You get a linear equation, you fix it, you get in standard form. what you're going to end up with is 4R1 minus 6R2 equals 200 times 10 to the minus 3. Make sure you get them in standard form. Here you have your coefficients, and here you have your constants. You should already have downloaded system equations, I think it's called, or systems, into your smartphone to solve simultaneous equations. This is two equations with two unknowns. You just solve them, and you find out that in the solution, R1 is 100 k ohm, and it turns out that R2 is 100 k ohm. They're both equal resistance values at 100 k ohms. Plug that back in at this point right here and see if you get 6. Plug it back in here and see if you get 4. Just as a check. Now you're going to have to go through this same design. I showed you how to do it, but you're going to have to go through the same design before you come to lab for limits of 1 volt and 5 volts and for limits of 3 volts and 7 volts. If you take a look, there's many ways of building this circuit, but the way that I'm going to have you build it is this way. I'm going to have you build it like this. You already looked at potentiometer and how the potentiometer is laid out. I'm going to have you go from, set this up here, over here to 10 volts. And here's your 10 volts coming out, and it's going to go to the rail. And here's your ground reference. It goes to here. I may have you use a power supply in lab and just alligator clip to this point right here. Just go up and set the power supply to 10 volts and take this to 10 volts and take this alligator clip this point to the ground reference on the power supply like you did last semester, rather than use this potentiometer here. Either one, 6 of one, half dozen of the other. But notice the circuit we're going to build here is this circuit right here. Basically, that's the circuit you have to build, right? Let me get the right one here. You're going to build this circuit right here. We're going to have 2 fixed resistors, and the pot's going to be in between them. So all I did was I turned my pot sideways here, and you have to know that this is going to be point A here, here's going to be point B, and here's going to be point C. You have to look underneath these to identify which one of these columns here are going to have your 3 different points here. Your point A, your point C, and your point A, your point B, this is point B at that point, and your point C. And the reason I turned this sideways like this is so I can get that screwdriver and I can put it in on the end right here, and I can rotate this. I can make this variable change in resistance without having resistors in the way. This resistor here goes from the rail, which is this point up here. It goes from the rail to terminal A, and it does. It goes from here to terminal A on the pot. There's the resistor. And then I take my pickoff point off the wiper, which I know is this pin right here. It's a whole row in there of choices, but you can't get to some of them because it's underneath the pot. And then terminal C is at this point here, and terminal C isn't going to go to ground now. Terminal C has to go through the resistor 2, and I do that. I take this through the resistor 2 and I take it to ground. This goes to the blue rail on this side right here. It's this point here. It's this resistor here that goes to ground. And then I take my output with the black wire right here. Here's my wiper, which is my output. So there's my voltage between these 2 points. That's the voltages I'm going to be measuring as you're going to alligator clip to the voltmeter, the red lead here and the black lead at this point, and then you're going to make a variation right here, and you're going to see in your design that when you put in your values for your first design, you should vary between 1 volt and 5 volt. You're going to show that to the instructor. Once the instructor okays it and that design's complete, you're going to remove these resistors here, and you're going to put in new resistors for the calculations you come up with for 3 volt and 7 volt design. You're going to call the instructor over. You're going to demonstrate your circuit. You're going to be able to change this pot, and the limits of this pot are going to go from 3 volts to 7 volts. Now the tolerance of the resistors, we're not using precision resistors. We're going to get resistors that are close to your design calculations. So you might end up with 1.2 volts here and 4.8 volts here as limits. If we took our time and used precision resistors, you could get very, very close accuracy here. But we want to be in the ballpark, and that's all we're really looking for. So that's what required for pre-lab number 3. Just explain the potentiometer, what a potentiometer is. You're going to be using them a lot this semester, so make sure you understand how to use the pot. This is how I suggest you put it into the circuit. Make sure it's accessible here with that screwdriver that we'll supply you with to be able to make a change on the pot. And just demonstrate the limits that you come up with in this design lab. And that concludes the lab lecture.